let's get right into it. Welcome to this explainer, where we're going to take abstract coordinate geometry and completely transform it into an intuitive, visual concept, something you can easily use to ace your upcoming grade 9 exams. If you've ever stared at a graph full of confusing floating dots and letters and thought, what is actually going on here? Well, you are in exactly the right place. Today, we're not just doing textbook memorization. We are going to uncover the true meaning behind the formulas.
We've got a great roadmap today. We'll start with some real-world math, break down the anatomy of the 2D Cartesian plane, map out our quadrants, decode the distance formula, do some step-by-step practice, and wrap up with crucial exam prep. Let's go.
Starting right off with Section 1, Real-World Math. So I want you to imagine a student named Ryan. Ryan is visually impaired, and he just moved into a brand new bedroom. Trying to learn a new space without seeing it is tough, right? Well, his sister Shalini did something amazing using the exact coordinate geometry you're studying right now. She actually built him a tactile grid map of his room. She took a board, set up a rectangular grid with pins, and connected them with thick wool to outline exactly where his door, his bed, and his wardrobe were. She scaled the whole thing so 1 centimeter on the board perfectly equaled 1 foot in real life. It's brilliant. Ryan could literally feel his way through the math.
And this right here is where the math truly comes to life. That physical space he was feeling perfectly maps onto a mathematical grid. If we just take the bottom left corner of his room and call it our starting point, we can suddenly pinpoint the exact location of his wardrobe using just numbers. We track along the horizontal x-axis and the vertical y-axis. All of a sudden, math isn't just weird symbols on a page anymore. It's a highly structured way to describe our actual physical reality. And that's really your first big takeaway today. Coordinate geometry is an incredibly practical tool for mapping out space.
Let's move into Section 2 and look at the anatomy of this grid we keep talking about.
The whole shebang rests on one specific spot, the origin. You can think of this as our anchor point. It's absolute zero, mathematically written as 0, 0. And from this origin, we draw 2 intersecting perpendicular lines. You've got the horizontal x-axis running left and right, and the vertical y-axis running straight up and down. Literally everything else in coordinate geometry is just about measuring how far away you are from this central anchor.
Now, quick history detour, because you might think this grid stuff is a modern invention. Actually, it dates back thousands of years. The ancient Sindhu-Sarasvatī Civilisation laid out massive city streets on precise 10-meter grids. But here's the really mind-blowing part. Our modern Cartesian plane relies totally on a 7th century Indian mathematician named Brahmagupta. He's the one who formalized the mathematical rules for zero and negative numbers. Without his pioneering work on negatives, the 4-quadrant plane that René Descartes formalized centuries later just literally wouldn't exist. So we're building on some seriously ancient breakthroughs here.
Which brings us nicely to Section 3, mapping out those specific zones.
So those negative numbers Brahmagupta worked on, they are exactly what splits our 2D space into 4 distinct zones, which we call quadrants. We number them counterclockwise, 1, 2, 3, and 4. And notice how the signs of your coordinates flip depending on which zone you land in. In quadrant I, it's easy. Both x and y are positive. But drift down into quadrant 3, and suddenly both your x and y values plunge into negative territory. Getting a feel for these signs is absolutely crucial for putting your points in the right spot.
Okay, listen up, because this right here is a massive exam tip. One of the most common mistakes grade 9 students make, and it breaks my heart every time, is swapping their x and y coordinates. An ordered pair is always written as x, then y. That means you measure your horizontal distance first and your vertical distance second. 3, 5 is a completely different location than 5, 3. My favorite way to remember this? You have to walk horizontally to the elevator before you can ride vertically up or down. Walk first, ride second.
All right, Section 4, let's tackle the dreaded distance formula.
If you open any math textbook, you'll see this terrifying, massive algebraic formula for finding distance. I want you to just completely ignore it for a second. Instead of blindly memorizing a bunch of letters, let's look at what's actually happening. Finding the distance between 2 points on a graph is simply using the Baudhāyana Pythagoras Theorem to find the hypotenuse of a hidden right-angled triangle. That is literally it. The horizontal distance is your base, the vertical distance is your height, and that straight diagonal line between your points, that's your hypotenuse.
Once you realize it's just Pythagoras in disguise, you can break that intimidating formula down into 3 super logical steps. Step 1, figure out your horizontal shift, so just the difference between your x values.
Step 2, find your vertical shift, the difference between your y values. In step 3, square both of those shifts, add them together, and take the square root. It is exactly the same as solving a squared plus b squared equals c squared.
So, let's actually put this into practice. Section 5, Example Problems.
Grab a piece of paper. We have point A sitting at 3, 4 and point D at 7, 1. I want you to pause this explainer right now. Calculate the exact distance between these 2 points using our 3 steps, and then hit play so we can check your work together. Seriously, try it out. Pause now.
Welcome back. Okay, let's see how you did. Step 1. The difference in x, 7 minus 3, gives us 4. That's our base. Step 2. The difference in y. 4 minus 1 is 3. That's our height. Now for the Pythagoras magic. 4 squared is 16, and 3 squared is 9. Add them up. 16 plus 9 is 25. Finally, we take the square root of 25, giving us a final hypotenuse distance of exactly 5 units. If you got 5, awesome job.
Let's level things up a bit with some negative numbers. What happens if we take those exact same points and reflect them like a mirror across the y-axis? Now our points are a prime at -3, 4 and d prime at -7, 1. Go ahead and pause again. Track your negative signs really carefully while you find the differences and solve for this new distance.
Okay, moment of truth. The answer is still exactly 5 units. When you subtract -7 from -3, your difference is 4. And 4 squared is still 16. This perfectly proves that geometric reflection preserves the length of the sides of our triangle. It doesn't matter if your coordinates are wandering deep into negative territory, that distance remains completely constant. Just always find your x difference, your y difference, and apply Pythagoras.
Let's land this plane with Section 6. Time to consolidate everything so you can secure that top grade.
Before you take your next test, keep this mental checklist of common pitfalls. Number 1, never ever swap your x and y. Walk before you ride the elevator. Number 2, be super careful when subtracting negatives in the distance formula. Remember, minus and negative turns into a positive. Number 3, do not get so thrilled about adding your squares together that you forget to take that final square root at the very end. And lastly, always double-check your quadrant signs.
Here is your absolute holy grail. Take a screenshot of this formula sheet right now. You've got the origin, the proper XY format, your beautiful distance formula, and a handy tip for midpoints. If you review this the night before your exam, you are going to be in fantastic shape.
Before we wrap up, I want to leave you with a bit of a mind bender to think about. How limited would our math and our maps be if ancient scholars like Brahmagupta hadn't conceptualized numbers below 0? Just imagine trying to map out a whole city or navigate the stars in the night sky if you were totally trapped inside quadrant 1. It's crazy to think about how discovering numbers below 0 literally unlocked the rest of the universe for us. Keep practicing those distance steps. Thank you so much for exploring this with me today, and I'll catch you in the next explainer.